Hello everyone, now in this video what I'll be doing is working test exercise 23 on Engineering Mathematics 5th edition K.A. Stroud. So we're told that we have two lines, one is y equal to x, and we have another one, y is equal to 16x, and they intersect at x is equal to 4. We're having to do double integration, and we're solving for the area enclosed by those two lines, and the coordinate at x equal 1. I'm looking at the point of intersection as x is equal to 4. So I'm not going to go and do a sketch. I'm just going to show you what the graph looks like that you see here. And now let's just move straight into solving this. So first things first, just using the technique I always use. We know that, and we have y is equal to 2x, and y squared is equal to 16x. Now since we're looking for y, we're going to root. So y is equal to 4, and let's say we have x to the half, not root. So let's use x to the half instead of root x. And now we have intersection. So the intersection is 4, and we have, so x is equal to 4 and x is equal to 1. So that's what we actually have. So we're going to make use of this formula here. So looking for the area is equal to double integral of dy dx. Now let's look at what we actually have here. We know we're looking at 1 and 4, and we have y1 and y2. Now you know what y1 and y2 simply based on this sketch. So going back to this here now, what we are now going to have here is equal to the integral of 1 to 4, and let's put y1 minus y2, and this is going to be dx. So what this is equal to is going to be the integral of limits 1 to 4, with y1 being 4x to the half minus 2x, and this is dx. Okay, so I'm just going to show you how I would go about and do the integration. I won't actually do it the method most persons will be familiar with, so this is what I do. So we have 4 root x to the, for the integration of x to the half. So this is going to be 4, and after we apply the rules, we have 2x to 3 upon 2 divided by 3. So this is going to be equal to 8 upon 3 x to the 3 upon 2. And of course this is plus c because we didn't actually use any limits, so it's so good to actually practice the methods beforehand that you all actually make use of. And next we have minus 2, we're integrating x, so we have minus 2 of x squared being divided by 2, so this is going to give me minus x squared plus c. Yes, I'm doing it all this way so persons understand clearly what steps I'm taking as I solve the problem. Good, so what this actually tells me is that a is equal to, I have 8 upon 3 of x 3 upon 2, which is subtracting x squared, and our limits will be 1 to 4. Now applying those limits, now I'm not going to go through the actual calculation, I'm just going to work straight into what the solutions would look like. We would have, using 4, we'd have 64 over 3. And using x squared, so 4 4s is 16. So that's our first bracket. And in our second bracket, we'd have 8 over 3 minus 1. And when we actually solve this here out, we're going to have basically 64, 3. We're going to have 56 over 3 minus 15, which is going to be 3.67 units squared. Now, in the next one, we're looking at an area. A solid is enclosed by the plane z is equal to 0, y is equal to 1, y is equal to 3, x equals 0, x equals 3, and the surface of z is equal to x squared plus xy, and we're calculating the volume of the solid. So let me just go straight into the, how should I say this? Let's just go straight into the formula that we're going to make use of. So this, just give me a moment, trying to locate where my cursor is. There it is. Yeah, for some reason I'm not able to see where the cursor actually is. I have no idea why that's happening. Anyways, so y is equal to integral, so we have x1, x2, we have y1, y2, we have 0, z1, we have dz, dy, dx. So let's just establish that for z, we know it's equal to x squared plus xy. And if you look at the top, you'd see that z is equal to, x is equal to, sorry, z is equal to 0, y is equal to 1, y is equal to 3, and x is equal to 0. Let me just change a few things here. Okay, actually I'll have to do it later on. Anywho, moving on. This should not be y, this should be phi. This needs to be phi. So that's phi. So, take note, we already have what z is equal to. We have z is equal to 0 and z is equal to x squared plus xy. We have what y is equal to, and we also have what x is equal to. So we actually, all we're doing is just filling in the information. So v is equal to, so for x's we have 0 and 3. For y's we have 1 and 3. Now we have 0 for z, and we have the z1, which is here. So we're just going to go ahead and write that, where we have x squared plus xy, leaving us with dy dx. So in applying now the integration in respects to y, our v is going to be equal to integration of 0 to 3. So notice that we have here x squared. So this is going to be x squared integral of 1, which is going to be x squared y. And then we have xy. So we're going to have x integral of y is going to be equal to xy squared being divided by 2. So writing that here now, we have x squared y plus xy squared over 2, and limits of integration being 1 and 3. Now, due to just due to space, let me see how I could write this here now. So v, remember that this is actually y values we're making use of. So keep that in mind as we go ahead. So we have x squared, and we have y being equal to 3 as the upper limit, plus we have x and y is equal to 3, which is going to be squared, being divided by 2. And this here, subtracting, now using the lower limit, we have y is 1, so we're going to be left with x squared, and we're going to have this added, so again y is 1, so we'd have just x over 2. So looking at the information that we actually have here, we're going to be left with v is equal to 3x squared plus 9x over 2, which is subtracting. Here we have x squared plus x over 2. And we work out these two brackets, what we're going to have. Oh shoot, I actually made a mistake. I should actually always remember to do this. 0 and 3. So this is actually 0, 3. So the integrating 0, 3. And when we work this out, we're going to be left with 2x squared plus 4x dx. Alright. And alright, so you have to integrate that now. So v is equal to, so we integrate of 2x squared, we're going to have 2x cubed over 3. And integration of 4x is going to give me plus. We're going to have 4x squared divided by 2, so that's going to be 2x squared. And limits of integration is 0 to 3. So of course with 0 there is just going to work out, so we just need to look at the upper limit. So this is going to be 2x, so 2 times 3 raised to the third is 27, times 2 is 54 over 3, plus 3 is 9, so this is 18, and this is equal to 54 over 3 plus 80, which is going to be equal to 18 plus 18, which is equal to 36 units cubed. Alright, yeah, so I know this is actually a return video. I need to get back into the groove of actually solving these questions and becoming more comfortable doing recordings. So I'll try and complete further problems for this section today. I actually have the time. And hope this video has found you well, and best of luck in this afternoon's quiz. Bye bye.